Okay. Yeah, so this is a project in Patna, which is a structural steel auditorium being built by Bihar Electricity Board. It's a a modern futuristic design and having 3D complex geometry. And this is the image which was presented to the electricity board during the bidding stage, and the same auditorium has been constructed at the project site. Next. Yes, so this is self-introduction about myself and the company, which I will just skip. Yeah, this is about the project. Like the project is in Patna, Bihar. The contractor is from Jharkhand, Kalsi Buildcon Private Limited, and it was a EPC project, like design and build project, by floated by Bihar government, and we supported it the pre-bid stage also, and we on the award of work we also did the detailed design of the project. The architect is Rajiv Agarwal Architects from New Delhi, and we did the structural design, and this design were proof checked by IIT Mumbai before the execution of the work. Mainly it consists of G plus 3-story residential reinforced concrete structures, having the foundation and substructure in reinforced concrete, and also balcony area in reinforced concrete, and covered with the high performance galvanized aluminum cladding and roofing supported on varying height structural steel portal frames that house the large span column free auditorium facilities. Its structure steel tonnage was about 210 tons, and approximately 55 kg per square meter was the consumption. These are the architectural plans and the section of the auditorium, and it was designed to be highly flexible and can be configured for 100 to 800 people. Yeah, so this has been discussed this is regarding the various standards and codes used for the design, list of the software when used, and the parameter considered. Being a Patna, it is a high wind zone as well as seismic zone. So why steel structure, like it has been discussed n number of times today, like it is like recyclable material, large spans are possible, large cantilever are possible, and it is easy to replace, and it is most suitable for 3D complex form and shapes, and it is also easy to replace steel member compared to replacement of reinforced concrete or prestressed concrete member. So for analysis and design as a structural engineer, we did in a two-part. We generated the first as a RCC part. We made two models, one in STAD and one in ETAPS, because we were having the issue in terms of the dynamic analysis as per the IS 1893 code. And in both like STAD and ETAPS, in dynamic analysis, the mass participation was quite less, even with the 100 modes. So we ended up in doing the static analysis with all the safety factors in place. So this is the 3D view of the STAD model, and also have this greens are the support of the steel portals, which legs are supported on these RCC columns and pedestals. So yeah, this is the structural steel portal frame model, which we generated in STAD and also in other 3D platforms to understand, visualize, and design accordingly. The outer shell of the building is cladded with galvanized aluminum and supported on steel portal through the purlins and the other elements. Like there are about 20 portal frames, steel portal frames are used, and those portal frames cover about 84 meter of length, and those are of varying height from 8 meter to 21 meter of height. And all portals are unique, like they all are vary in height, width, and angle and everything. So those are perfectly tailor-made for the required aesthetic, and those are the prefabricated eye girders of having varying wave depth and flange widths and meeting the aesthetic requirements. The key feature of the project is like this 11.2 meter cantilever for the entrance for coming out from the last portal. So this was designed in combination with the built up hollow section supported with the other portals through tie beam and the bracings, horizontal and vertical bracings. Yeah, sure. So this is again that few images related to this cantilever portion having the hollow, fabricated hollow box section specifically for this project. For roofing, we have used this standing seam linear roofing and cladding system, which is ideal for 3D form and shapes envisaged in the architectural design. Like we have to do the extensive exercise for the working of the purlins and the dummies and other areas, which one of the example has shown, like architectural team and our team has worked effortlessly to make it happen. This is the image of the ongoing fabrication. This is the image of the connection worked out by us. Initially, the bolted connection were worked out, and then it was transferred to welded connection as per the request of fabricator. These are the images of the connections. This is again the installation of all the portals. And in this, you can see the actual 3D, the plan 3D image and the actual construction at the project site. So you can see it's almost, everything as envisaged was achieved in this project to the required accuracy and the precision. So this is the left one is the initial 3D image, and the main one is the completed image of the project. Thank you.